All right, my friends, let us begin our separation of variables, differentials unit. In this scenario, it's either separating the variables, derivatives, blah, 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 and any of that stuff. So go ahead, take a moment to read the question. Okay, here we go. So it's talking about a landfill. It's talking about solid waste, which is poo. This problem's about poop. At the beginning of 2010, a landfill contains 1,400 tons of solid waste. It gives us this information, dW dt, which gives us our derivative for the next 20 years, right? So planners estimate that will satisfy. And it's a total amount of solid waste stored. So it's basically, this is the equation that will tell us how much solid waste is stored there. W is measured in tons and T is measured in years. Use a line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months that you're there. Right, good. All right, very good. This is line tangent. We know immediately that means Y minus Y1 equals M. X minus x1, but now I want to double check. You're always okay to write y's, but this problem, our function is t's, so better yet, y minus y1 is equal to m t minus t1. There we go. And let us begin. So how do we get our tangent line equation? Well, it says that t equals 0. Beautiful. So when t is 0. Now, do we have any information about when t equals 0? Well, if you look at the beginning of the problem, at the beginning of 2010, the landfill contained 1,400 tons of solid waste. So when t equals 0, we know that y value is 1,400. So this is y minus 1,400 is equal to, and we get m t minus 0. M, we usually take the derivative and plug it in, blah, blah, blah. But here's the thing. We can't plug in 1/4 into this equation. There's no t. So how do we get our slope, dw dt? Well, that's going to be 1/25. Well, w represents the waste, right? That represents the waste, which we do have right here, 1,400, right? That's the waste. So this will be 1,400 minus 300. 1,400 minus 300. I do believe if I do some mental math, that's 1,100 divided by 25 is this is 1,100 divided by 25 is 44. There it is. Oops. Okay. So we know y minus 1,400 is equal to 44t. And we know it's 44t because this is t minus 0. We don't need the 0. So there it is. And we have our tangent line approximation. Now the problem says approximate the amount of solid waste that the landfill contains at the end of the first 3 months, which is t equals 1/4. So let's plug in 1/4 into this equation. Y minus 1,400 is equal to 44 times 1/4. 44 divided by 4, I do believe, is 11. So we get y minus 1,400 is equal to 11. And now let's add 1,400 to both sides, which we're going to get y is equal to 1,400. There it is. Bam. 1,400. And what is W being measured as? 1,400 waste of what though? Well, W is measured in tons. So 1,400 tons. Boom. And that takes care of that problem for us right there. And then we are in business. All right, my friends. So that's kind of how we can approach this problem. Very tricky nonetheless. Let's go ahead and go to the next sub question here. At the beginning of this, oh yeah, we already read that. Find D2 of the, or basically, what am I saying? You know that means take the second derivative. Well, we already have the first derivative, so we need to take the derivative of that, right? And that's really the biggest part that we want to do, is we want to be able to take the derivative of this and then be able to plug in information that we can. Now, again, I think if you're on the AP exam, and maybe for some of you that might seem a little hard right now, and that's not a big deal. As you guys know, the big money question, especially when you're dealing with this, is going to part C. which I've highlighted. You can see pretty big. It says find the particular solution W equal W of t to the differential equation with initial condition W of 0 equals 1,400. And I think that's really important, team, because remember, this question is worth 5 points. So before I even go to part B, I'm going to go ahead and do part C, right? Part A, I think, is something that you feel probably confident in. You can do that. It's worth 2 points. But part C is really where the money's at. So I might, on the AP exam, this might be the one question you really try to find, because you can get 5 points here. So we need to find the W equal W of t. This is basically asking for the original equation with initial condition W of 0 equals 1,400. Okay, very important that whatever you plug into here, notice how this is t. So this represents your t, and this should represent your w. So let us begin. We have dw over dt is equal to 1 over 25 w minus 300. Now, in order to get to your original, we're given derivative. What do? That's antiderivative. But notice how we have dw over dt. Well, if you guys remember, that means we're going to have to separate the variables, right? And so let's go ahead. We're going to multiply dt to both sides. And I'm going to divide both sides by w minus 300, right? Divide by w minus 300. So as you guys can see here, our dt's cancel out. Boom, boom. Our w's cancel out. Our variables are separated. Let me go ahead and write them down. 1 over w minus 300. Okay, dw is equal to 1 over 25 dt. Now that our variables are separated, let us go ahead and take the antiderivative of both sides here. Well, what's the antiderivative of 1 over w minus 300? Well, keep in mind that there's no power on the exponent. So this is going to be ln absolute value w minus 300. Okay, don't forget, we still need to take the derivative of the inside, which is 1, and then we are going to divide by that. But, well, 2 divided by 1 is 2, so there's no need to put the division of 1, so we're good. So that part is taken care of. Okay, what's the antiderivative of this right over here? Well, the antiderivative is, 1 over 25 times t plus c. Right? It's just like if you had, what's the antiderivative of 3 with respect to x? That'd be 3x. Why? The derivative of 3x is just 3. What's the antiderivative of 1/2? That's just 1/2 x, because the derivative of 1/2 x is 1/2. So don't let the fraction confuse you. And it's dt's. It's just 1 over 25 times t plus c. There it is. That's our proper antiderivative. Now we are in business to go ahead and basically solve for our c value, right? So we're going to get ln absolute value. We know the y value in this scenario when we did this right up above is 1,400 minus 300 is equal to 1 over 25 times 0 plus c. All right, now in case you're confused, that came from this. This is the initial condition, which goes into here, and this is going to go into your t value. Very good. And we get, this is 0, so c is equal to, this is ln absolute value of 1,400 minus 300 is 1,100. What's the absolute value of 1,100? That's just 1,100. There it is. Let's go ahead and plug that back into my expression. ln of absolute value minus 300 is equal to 1 over 25t plus ln of 1,100. Now that we have our c value, we are in business to solve this out and try to get our expression. Well, let's raise both sides to the power of e to get rid of ln. Okay. Once I raise e to both sides, that's going to raise this entire thing to the power of e. This e and ln will not these will not cancel out because there's a plus symbol in between. These are right next to each other. These are going to cancel out, and we're going to be left with, let me just scroll down, w minus 300 is equal to e to the 1 over 25t plus ln of 1,100. Let's go ahead and add 300 to both sides. That cancels out. W is equal to e to the 1 over 25t plus ln of 1,100. And let me just put an extra set parenthesis, plus 300. Bam, there it is, right? That's 5 points that I can get. And that's why we want to be very cautious on how we approach this problem, because it's great points that we're able to get for these. Anyhow, let's go back and do part B, just for the sake of it. Here we go at the beginning of this time. We got all this information. We're taking the second derivative, dw dt is equal to 1 over 25 w minus 300. As you guys know, whenever I see a number and I need to take a derivative, I'm going to just distribute it real quick. I'll get 1 over 25 times w, and this is minus 300 divided by 25, right? Basically, 1 times 300 is 300 divided by 25. And honestly, I don't even care what that is, because I'm going to take the second derivative. Okay. What's the derivative of this right here? Well, it's 1 over 25 dw dt, because again, this is with respect to t, and there is no t in our expression. What's the derivative of any number? Gone, 0. Beautiful. So just by writing this down, we're already getting points, right? Now, do we know what dw dt is? Well, dw dt, right, is actually right here. It's given to us. So this is 1 over 25 w minus 300. Bam. Right, and now we kind of simplify this through. We get 1 over 625, which is going to be w minus 300 right there. Very good. Now, we found our second derivative. Now, use this to determine whether your answer in part A is an underestimate or an overestimate, right? And this is probably going to have to do with it being concave up or concave down, right? And we want to know whether this approximation that we're doing here is going to be an underestimate or an overestimate. Now, what does make this question kind of hard is it involves a few things, right? So again, for now, right now, as you're doing your homework, I just want you to focus on the problems that matter the most. This question here I will provide separately on the answer key for you to look over if you really want to make sense of it. But for now, if I'm taking the AP exam, all I really care about is for you to really 100% of the time get part A, and part C has to be beautifully done and be done correct, right? Because that's going to be 7 out of 9 points. You got 1 point for taking the second derivative, and here this is a little bit of, it's not too bad, but it takes a little bit of work just for 1 point. So that'll be on the answer key. We'll call it a day, because if you look, it's already been 13 minutes, right? And I'm only giving 15 per question.